Now in this part 3 of 3, we will go through the entire process of solving differential equations with exact form. And here are the steps that we'll be going through. So to solve this differential equation, we want to first check for exact form. We do that by taking the derivatives of the m with respect to y and the n with respect to x and see if they match. Since they do, we know that this is in exact form. If it's already in exact form, we can find the potential function by either integrating the m with respect to x or the n with respect to y. Now, I've just chosen the n to integrate with respect to y. Here's the integral. Remember, the constant of integration is some function of x, since we're integrating with respect to y. We do the derivative of that with respect to x, and we set the two equal to each other. Solve for the h prime and integrate to find h. We put these together to form our potential function. Now, once we know the potential function, we can write the answer. We would like to be able to make that y is a function of x. However, we're not going to do that with this one because we can see that because y is squared, it's not going to be a single function of x. For this one, we will start by recognizing the m and the n and checking for exact form. The derivative of m with respect to y and the derivative of n with respect to x do not equal, so it is not in exact form. We will check to see if we can put it in exact form. Now, this requires us remembering the special relationships. So when we do the partial of y, m with respect to y, and the partial of n with respect to x, subtract and divide by n, and simplify, we do not get a function of x. Let's try the other one. When we do the partial of n with respect to x and the partial of m with respect to y, subtract and divide by m, and simplify, we get a function of y. That tells us that it can be put into exact form. We need to find the integrating factor to put it into exact form. So we'll do the integrating factor by doing the e to the integral of negative 2 over y dy. So our integrating factor comes out to be y to the negative 2. So we multiply the original differential equation by y to the negative 2, and we have a differential equation that's in exact form. Now we solve that. So here is our m and n, and again they do match now because we just made them match. And we'll take the m and integrate with respect to x to find at least part of our potential function. We will set the two partials equal to each other. Partial of y here, partial of y here, set them equal to each other. Solve for the h prime, and then integrate to find h. And put that together with what we found earlier. Now, again, we're not going to take the time and effort to try to recover a single function, because I can kind of tell from looking at this that it's not going to happen.